Travel routers are great. They let you take your network with you anywhere. But what if you could take your entire Homelab with you instead? A router, NAS and Docker server all inside a rack that's small enough to fit into your backpack. So I tried shrinking my 10-inch lab racks design down to the smallest size that could still run a real Homelab stack. And this is the result, a 5-inch rack. This is a 50% scale version of my 10-inch lab racks design, but still fits a Raspberry Pi-based OpenWrt router, a network switch, a NAS with an OLED stats display, and a Docker server with a Grafana monitoring dashboard. So in this video, I'm going to print and assemble the rack, install the hardware, and see if a portable Raspberry Pi-based Homelab actually works. To start out, I opened up the original model for my 10-inch rack and then made some changes to scale it down and still keep it easy to print and assemble. It keeps a lot of the same proportions of the racks too, so one new 10-inch model can be shrunk down to 50% scale and should then fit into this rack. So let's get the rack printed out as a start. Because it's been shrunk down, it's actually really easy to print. The whole print fits onto a single build plate and uses just 220 grams of filament. I printed it out in grey sparkle filament with translucent yellowish green accents. I also separated the bulk colours over 2 build plates, which makes printing a bit faster. I think the parts have come out really nicely. This design uses M3 by 8mm screws to hold everything together, and I'm using some M3 brass inserts in the top and the base instead of having to press nuts into pockets. I think these make a stronger and easier to assemble build. These are just pressed into place using a soldering iron, 4 for the vertical posts and 4 for the feet and handles. And then the same for the opposite side. For the holes on the vertical post to mount the racks onto, I also used M3 brass inserts. I used slightly shorter ones for these because I had a box of them lying around, but they're the same diameter as the longer ones and both work just fine. I'm only putting them into the top and bottom hole for each rack unit rather than all 3. With the inserts installed, assembly only takes a couple of minutes. We start by installing the 4 posts on the base with a single M3 by 8mm screw holding each one in place. The 2 side panels then slide down into recesses in the posts. I've kept this design feature in the 5-inch rack as it makes it easy to customize with open sides or add a fan or even a cable entry cutout. Then the top cover can go on, with 4 screws holding that onto the top of the posts. The tiny handles can then be screwed onto the top, each with 2 M3 screws. At this scale, the handles are more decorative than functional, but I think they serve their purpose. Lastly, the 4 feet on the bottom finish it off. As with my previous build, you can also print these out in TPU for a more flexible finish. And that's the rack complete. Honestly, because it's been scaled down from the original lab racks model, it's difficult to tell how much smaller it is. But it is quite noticeable alongside the original. It's actually now 8 times smaller in volume. So what does that mean for components that we can fit into it? Well, at 5 inches, we can still comfortably fit a Raspberry Pi into a single unit. And by trimming some fat off a 5-port switch, we can build one of those in too. So there's still potential for a decent setup. So to turn this into a real portable Homelab, here's what I'm installing. A 5-port gigabit Ethernet switch, which has been stripped of its TP-Link plastic housing to save on space. This now easily fits into a single rack unit. Then I've got this little board with dual Ethernet ports and a Raspberry Pi Compute Module 4 on the bottom. It's also got a USB-C port for power on the front and another on the side for peripherals. I'm going to load OpenWrt onto this board as the router for my Homelab. I don't need it at this stage, but Wi-Fi can also be added through the USB port on the side. Then I've got a single Raspberry Pi 5 with an active cooler on it, which I'm going to install Pi OS Lite onto, and then run Docker on it for all of my network services and for monitoring. And lastly, my setup wouldn't be complete without a Raspberry Pi-based NAS. and this takes up 2 rack units. So I've got a Pomeroni NVMe base with a Lexar NM620 drive for storage. Alongside that's an I2C OLED display which will display my stats script. You could also use a dual NVMe base for 2 storage drives. And these are both connected to an 8GB Raspberry Pi 5. And I swapped the small heatsink out for an active cooler too. Now let's get those installed in the rack. From the top down, I'm installing the router, then the switch, then the Pi NAS, and lastly the Pi running Docker at the bottom. And my mini travel Homelab is now complete. There looks like there's lots of room around components for airflow. I'll keep an eye on the temperatures, and if they become an issue, it'll probably be best to install a 60mm fan on the side panel blowing across the racks. It's actually a really powerful little stack for its size. Having its own OpenWrt router means that I can do anything I could have done with a travel router, but now automatically applied to my little Homelab. I can create advanced firewall rules, and have full control over my network's DHCP and DNS settings. I've also got network attached storage that allows me to share files and folders across all devices on the network. And it can do automated backups and even cloud backups when the router is connected to the internet. And the Docker Pi is available to run any other services that I need local when traveling. So I could have a completely offline and portable local network with all of my files, a media server and automated backups. It's even got some cool monitoring dashboards available through a browser on the local network. This one's through NetData, and I've got another one running Prometheus and Grafana. So that's my new 5-inch portable home rack. It's small enough to travel with, but still powerful enough to run a full Pi-based Homelab stack. I'm curious though, what would you put into a rack this small? Let me know in the comments section, because I'm already thinking about some upgrades for version 2. Thanks for watching. Please remember to like this video if you enjoyed it, and subscribe for more tech and electronics projects, tutorials and reviews.